Distillation is a very traditional method for separating the various boiling fractions of petroleum liquids dating back to the early 1900s, initially involving numerous cumbersome glass apparatus that required manual handling and adjustment. Distillation is still a very important test performed on distillate fuels and gasoline. It is run in heavy volumes in most petroleum labs around the world, as it gives essential information on the composition of petroleum products and fuels. Although automated equipment has been on the market for many years and has reduced the workload for labs as compared to manual operations, the market continuously demands higher efficiency and ease of use to run these tests. Tanaka Scientific's latest automated distillation tester model, the ad7, has been designed to accommodate the market's needs, with special focus on convenience, versatility, safety, and reliability. It is quite easy to start a test. Simply select the sample name, operator name, and test mode, and press Start. Most sample types are pre-programmed in the test mode list. The ad7 is equipped with a meniscus measurement mode. After placing roughly 100 milliliters of sample into the cylinder, this mode will measure the exact liquid level and define that level as 100%. This function is especially useful when sufficient sample is not available. The presence of flask and cylinder, cleaning of the condenser tube, and the hole diameter of the flask support board are all automatically detected. This prevents false start of a test. The current temperature of the condenser tube and the receiver chamber can be easily distinguished. When the values are in red, it indicates that it has not yet reached the target temperature, and the test cannot be started. When the numbers are in yellow, the instrument is ready to start. The distillation graph can be customized according to user preference. Two parameters can be displayed simultaneously, and the parameters can be chosen from observed temperature, corrected temperature, evaporated temperature, heater output, and distillation rate. By selecting the distillation rate, it is easy to confirm whether the rate is within the method limits or not. The instrument is equipped with a pressure sensor and will automatically calculate the corrected temperature. It is also possible to manually input the pressure and residue after a test. By utilizing the Heat Optimize mode, the heater control parameters for an unknown sample can be optimized automatically. By entering the parameter file of the next test into the reserve mode, the instrument will automatically adjust the parameters after the current test is finished. When the heater has cooled, the instrument will be all set to start the next test. In the QC database, allowable tolerances of test results can be defined. When a test is run with reference to a QC data file, the instrument will judge whether the results are within the defined tolerances or not. The instrument can also save and display historical results related to a QC file, which can be utilized as a quality control chart. By entering the density of the sample after running a distillation test, the instrument can calculate the Seton index and drivability index. In case of a fire breakout around the distillation flask, the ultraviolet sensor will detect the flame and automatically spray carbon dioxide gas to extinguish the fire. By utilizing Tanaka's data acquisition software, TDOS, operation of the ad7 can be further enhanced. Up to 10 instruments can be connected to one PC via LAN or serial communication cables. From the TDOS software, all connected ad7s can be controlled and operated. Furthermore, historical data can be saved, recalculated, and searched. The software can also be set up to transmit results to a LIMS system automatically when a test is finished. making this software a very useful tool for customers who want to manage test data on their system.